In this video, we're going to explore how to create an integration test of using Retrofit to parse JSON with coroutines. We're going to use test-driven design to create this unit test, so we're not actually going to parse the JSON just yet. We're not actually going to use Retrofit just yet. We'll cover that in a future video. In this video, we're simply writing the integration test as part of our test-driven design strategy. Now, an integration test is typically testing multiple classes working together, possibly even with some external data, which we're doing in this case, as opposed to a unit test where we're only testing one class in isolation. So with that being said, let's take a look at our class diagram and remember what exactly we are testing. So we have our UI package here with our activity and our view model. And our view model has live data. The live data is observed by the activity. We will cover that in a separate unit test that will follow this test. What we're looking at right now is what actually populates that live data. So in our case, the live data is a series of plant records that we're receiving in a JSON format. We're going to create a retrofit call to receive these, and then we're going to parse them into a series of objects that we can consume and show to our user in some type of autocomplete text view. So the parsing is going to be accomplished by Retrofit, a library, and that library requires that we create a DAO. That DAO is going to be called by our plant service class and our service layer. So the integration test that we're writing is our plant service class, and specifically a fetch plants method that's going to invoke this DAO, that's going to invoke Retrofit. It's going to go over the internet and receive data, and then take that data, parse it, and return that data to us as a series of plant objects. So you see we have at least three different things we're testing here. A DTO, which is a class, a service, and an interface, plus the library, plus the network interaction. And the network interaction gets a little bit tricky because we need to run any type of network operation in a different process so that we don't block the user interface and the user interface can still be responsive to user input. That's just a rule in Android. Anytime we're doing any kind of network connectivity, we have to do it in a different process. And in Kotlin, we typically use coroutines. Now, if you're not familiar with coroutines at this point, don't worry just yet. We'll take a deeper dive into that when we actually do a retrofit call. But given test-driven design, we just have to know that they exist and that we know that we need to write our test around them, or write our test to account for them, in other words. So I will focus on that in this video, what you need to do to run a test that spawns across multiple processes. And then we'll take a deeper dive look at coroutines later. And the secret to that is something called runTest, which will execute our test body essentially in its own coroutine. It has a bit of a goofy syntax, so let's start writing our test, and then we can come back and take a look at how we can implement this runTest operation. I'm in my development environment now, and I've created a new branch called TDD, BDD, and Parse JSON with Retrofit. Since we're doing test-driven design and behavior-driven design, and then we're doing the implementation, I'm simply putting this all in one branch. I'm going to go to my app.plantdiary directory, and under the test directory, I'm going to create a new Kotlin file, and we'll call this one plant tests. Now, we have to do a bit of boilerplate and put in something called a test rule, which says, let's run all of these tasks synchronously. It doesn't know where this is, so let's get the dependency. We'll go to the build Gradle in the app module, and under the dependencies section, I'm going to add a new entry. Android X Arch Core Testing 2.1.0 is the latest version as I'm recording this video, but of course, always go out, check out for one more recent than this when you're actually watching. We'll go ahead and sync. Now that the Gradle sync is finished, we can simply Alt-Enter and import this Instant Task Executor rule. Now, in true test-driven design, behavior-driven design, we'll start with some requirements, and then we will elaborate those into a series of examples in given when then syntax or Gherkin syntax. And those examples essentially become the script for our unit test. So let's take a look at this requirement. As a user interested in plants, I want to be able to search plants based on any part of the name, genus, species, cultivar, or common name. Dependencies, plant search data are available and accessible. Scientific names are in Latin. Common names are stated in English. Now we have given a feed of plant data are available. When I search for redbud, I should receive at least one result with these attributes: genus Ursus, species Canadensis, common eastern redbud. Now we want to make a test method that is very descriptive and we can easily identify with this unit test. And we want it to be descriptive so that when we see the results, we know exactly which test passed or failed. So there's a little shortcut we can use in Kotlin when we're doing unit testing. We can name our function, starting with fun, and then use the tick symbol, which on a US keyboard is typically the same key as the tilde. So be careful. It looks like a single quote. It's actually that little tick symbol that you never really use. So now we can put spaces in the function name. And this is typically something we do with unit tests and only really with unit tests. So given plant data are available, when I search for redbud, then I should receive Ursus canadensis. And then once again, the single tick, open and close paren, open curly and close curly, and that's a legitimate function. Now, we also want to add the @test annotation on top to indicate that this is a unit test. And we'll go ahead and say org.junit. Inside of a test, we can make certain assertions. So we can do something like assert, and then simply true, asserts that whatever is within those parentheses is true. We can also make something like an assert equals. And we'll typically put our expected value, and then we will have the computation that follows. And we've actually seen these before. If you remember, I did a few videos where I showed how to use branches with Git and GitHub, and I just wrote some simple unit tests in another class. So we've actually seen these before, but this will give us enough to make sure that our test can run. So I can right-click here and choose Run, and we can let it go. And after just a moment, we get a notification here and here that our tests have passed. We can scroll down and take a look at the results. And if I scroll to the right a little bit, we see specifically, given plant data are available, when I search for redbud, then I should receive Ursus canadensis. So we can see conclusively at this point that our test is passed. Of course, we're not really testing anything serious just yet, but we will get to that in the next few steps. Since we've been very descriptive in this function, we could write the whole unit test in this function, but another option is to write a series of given, when, then functions that this function calls. So I'll say given plant service is initialized, and we'll go ahead and, of course, we're calling a function that does not yet exist, so it gives us a little red light, but that's going to help us out. Alt-Enter, create function. And for this, we simply need to instantiate this plant service class that we saw before. Remember, we have not yet created that plant service class, but that's the nature of test-driven design. We create the test knowing that the code does not yet exist, and then we create the code to make the test pass. So we're probably going to use this plant service in multiple places, so I'm going to declare it as a variable up above. We'll say var plant service, plant service. Notice we have the variable name plant service, lower camel case, and we're giving it a type of plant service. We're not defining anything to it yet. We're not initializing it just yet up here. So I'm going to add one more thing in Kotlin, which is a keyword called Latenit. And that simply means let's go ahead and define the variable now. We will initialize it later. Now, we have to do this because of Kotlin's nullability handling. We typically don't create a variable and assign it to null, or leave a variable unassigned and assume it's going to be null. We simply say Latenit so that we can give it the scope of the entire class. And then we have an assumption that we will be initializing it later. And that's exactly what we can do down here. Given plant service is initialized, we can simply say plant service, referring to that variable, equals plant service. Remember, in Kotlin, we don't use the new operator, and also we don't need to terminate our lines with the semicolon. Also remember, we've not yet created the plant service class, so this will not compile, and that's the intention of test-driven design. Let's now work on the when part. When plant data are read and parsed. And once again, we'll create function. One thing that's weird when we create them in this order is they kind of end up getting created immediately under whatever function we're currently in. So I like to rearrange them a bit so it's a bit more readable. Of course, it doesn't matter what order the functions come in our class file, but I like to keep them in that given when then order. So when plant data are read and parsed. Okay, so plant service is what's going to interact with our DAO, which is our retrofit DAO, which is going to go fetch data and return that data to us. So we need a method that's going to kick off this fetch data and return data to us. Let's call it fetch plants. Now, what do you think fetch plants will return? Probably a collection of plants. So let's go up above and declare one more variable, var all plants, and then we'll give it a type of list and then plant. Remember, plant is a DTO or a data class that we created in an earlier video where we have genus, species, cultivar, and all of the things that will essentially describe a plant. Now, this is interesting because I do want this to be nullable because I want to be able to test for nullability. So in Kotlin, if you want a variable to be nullable, you simply add the question mark, which means this is allowed to be null. Now, I am going to go ahead and initialize this to an initial variable now. We'll say array list plant, and then simply open and close paren, which simply constructs an empty array list. Now, down below, where we have plant service.fetch plants, let's assign all plants to the return of this function. Once again, we know this function does not yet exist, but that's why we're doing test-driven design. And you can probably read from this, we're going to do a fetch operation, we're going to get back a collection of plant objects if we want to be successful. And so that's what we're going to verify in the then part. I have to add one small correction that I found after I recorded this video. Because fetch plants is going to be calling an asynchronous task, it has to be a suspend function, which means that it can be started, paused, and resumed. So anything that calls it has to be a suspend function as well, or has to be performed as a coroutine. So moral of the story, just remember, add this word suspend between private and fun. You won't see that in the rest of this video just because I realized it after the fact, but I will make sure that GitHub is updated with suspend. And just make a note, the when should have the suspend because it's calling fetch plants, and that's what's going over the internet and grabbing the JSON data, parsing it, and making it available to us. Let's work on the then. So let's see, given plant data are available, so we have our initialization, and then we have our when plant data are read. When I search for redbud, then I should receive Cercis canadensis. Now there is one little caveat here. The search for redbud we're actually going to do with an autocomplete text view on the user interface, so that's going to be handled by the UI. So we just need to get all the plant data and verify that Cercis canadensis exists in the plant data. So I'm going to add a then the plant collection should contain Cercis canadensis. Cercis canadensis is the genus and species for eastern redbud. So once again, just do a little moving around here, keep it nice and tidy. And I'll tell you what, I'm going to go ahead and take these asserts and move them down into our new then. And we'll tweak those a little bit to be a bit more obvious. So first of all, let's go ahead and do that assert not null. And let's assert not null on all plants. And then let's say, well, let's see, we need to import this. So assert not null from JUnit. And we'll say assert true, all plants is not empty. Now here's a tricky thing. There's a curly here because it says, wait a minute, you're trying to call a function on something that is nullable. But remember, we're checking for nullability up here on line 36. So we're allowed to do something that we don't often do in Kotlin, which is a double exclamation, which means that we are going to assume this is not null. But remember, we've already checked for nullability, so we're allowed to do that up here. So if you have a nullable variable, and you need to do what's called a force unwrap, which is you need to assert or you need to attest that it is not null under the covers, you simply take the variable and add the double exclamation, and that says this is not null. If it is null, and you've used that double exclamation, you will get a null pointer exception. So just be aware of that. Okay, and then we'll import the assert true. A couple more things I'm going to do is we want to make sure that that contains Cercis canadensis. So what I'm going to do is say all plants, and then we can use the for each construction in Kotlin. If we have a collection, we can simply wrap for each around it, and that essentially creates a for each loop for us, where it is shaking hands with everything in that all plants collection, and every time it shakes hands with a plant, it puts it into a special variable called it. So I can say it.genus. Take a look at that. Do you notice how common, genus, and species appear? Well, where do those come from? Well, let's go back just for a moment here. Let's look at our plant class and genus, species, and common. So you see that this it variable is an iteration variable on the all plants collection. And what that means is it's shaking hands with each individual plant, putting it into that variable, and then we can access the attributes of that plant object on that variable. So I can say it genus equals Cercis. Let's make an if test out of this. If it genus equals Cercis and it species equals canadensis, just like so. And then close out our if test. Then we can put some kind of Boolean in here that we can test for in just a moment. But I'm a little bit nervous because you see this all plants is redlining again. And again, there are better ways to handle nullability than a force on wrap. But in this case, because I've already asserted it's not null, the test would have failed here if the plants collection were null. So I feel comfortable doing the double exclamation. There's a better way to do it with what's called a let operator, but that's complexity we don't want to worry about just now. Right now, we're simply concerned with, do we have at least one plant that has Cercis canadensis? Well, I'll tell you what. Let's start by declaring a Boolean variable. So we'll say var contains Cercis canadensis equals false. We'll assume that it does not contain a Cercis canadensis. And then only once we've confirmed that our plant results do contain a Cercis canadensis, then we'll switch that from false to true. And then finally, when this test is over, we can assert true and pass in contains Cercis canadensis, just like so. So that wraps up our test for the most part, with one exception. We know it's going to do some heavy lifting here because it's going to have to go out and actually reach a JSON stream over the internet, parse that stream, put it into our plant collection, and then test that collection. And we know that it has to do that in a separate process or a separate coroutine. So we still need to solve for that separate coroutine. The way we do that is kind of tricky. Do you notice that we have our function here on line 19, and we have our open and close paren, and then we have our function body? Between these two, let's put in runTest. Let's put in equals runTest. That requires another dependency in our build.gradle file. So let me go ahead and put in org jetbrains Kotlin X coroutines test 160, and then hit sync, and we'll give that just a few moments. And now back to our test file, and we can import this runTest operation. Now, this syntax, when I first saw it, really confused me because we have a function call, we have the parameter list, and then we have the open and close curly, and then between that we have this equals runTest. So I wanted to do a little bit of a deeper dive into this and explain what's going on. It uses a few shortcuts. So remember, in Kotlin we can have a function that looks like this, and I've put it all on one line. So you have function getName, which returns string, and then we have return Brandon. And of course we'd have open curly, then usually new line, then return Brandon, then close curly. Well, in Kotlin, we can simplify that to just fun getName equals Brandon. Just a shortcut where we can declare a function, and if it returns something simple, we'll use the assignment operator, and then whatever it returns, and it just takes away all that extra syntax. Now, let's also remember that Kotlin is a functional programming language, and so we can take functions and assign them to variables. So this getName is assigning the getName function to the variable foo. Remember also that Kotlin has the concept of high-order functions, which is where you can have a function that accepts another function as a parameter. So here's a function called funFullName, and then that is going to accept a parameter called function_to_run, and it just accepts a function that does not take any incoming parameters and returns a string. So this is a signature for a new function called fullName. Now you can probably see what we're doing here is we're going to invoke this function called full name, and we're going to pass in the getName function as a parameter to the full name function. And it looks like this, full name, foo, where foo is the variable that holds the getName function that we have declared up in these first couple lines. Now there's yet another shortcut in Kotlin, where if the last parameter passed into a function is a function itself, or a lambda that represents a function, we can actually just invoke the function and then have an open curly and a close curly, and we essentially create that lambda or that inline function, and we just pass it right after the function we're calling. That is super confusing, I know, and it threw me for a loop, which is why I wanted to explain it here. But effectively, full name return Brandon consolidates everything we're doing up above. Wow. Let's go back and take a look at how that looks in our test. So in our test, we have this runTest function. And to the runTest function, we're passing this function for it to run. Now what runTest is going to do is it's essentially going to run all of that in one process. Then it's going to take the result, which is a test result, and it's going to assign it to this function. And this is the function that we're calling with the test annotation. If that doesn't make a whole lot of sense, don't worry too much about it. Just know that by adding these 10 characters that you see right here, you're taking a test that's going to run across multiple coroutines, and you're essentially saying, hey, could you run this all in one instance, please? That's all it's doing. Just that deep dive was to help to explain why that syntax looks a little bit funny, maybe if you're a Java programmer. So that is our test, and our test is complete aside from creating this plant service class. And once created, we'll need to create this fetch plants method that we'll call a DAO, that we'll call retrofit, get our data, parse our data, return our data back to us as a list of plant objects. This video is just based on the test-driven design, so let's save all that work for a future video where we will do the implementation. Briefly, though, I can show you another project I have that uses the same construction with runTest in a very similar given when then, where this time we're just parsing countries. So we have a country service, we have fetch countries, and then we assert null and assert not null and assert true in the then part. And I can show you simply by hitting run here that in just a moment we will see successful results from this. The only difference is we're looking at different data. We're looking at country data versus plant data. And sure enough, we see test pass, one test pass, and if we scroll down to the bottom and we scroll over to the right, we'll see that our given service connects to countries, so on and so forth, and we see that our test has passed. I hope this video has been helpful, and I look forward to reading your comments. Thank you.